Alright, so this is video number 13 of the boxMan tutorial, and I am very glad to say that it is video number 1 of binding, and hopefully the only video. First of all, as you guys saw if you watched all of the other rigging tutorials, rigging is a very tedious process. Of course, people consider binding to be more tedious, not because it's more complicated, just because it might be harder to achieve the result that you want. There's two types of ways of binding. Well, actually, before I get into binding, I just wanted to say one more thing. Basically, you want to make sure that all of your layers work. So all I did was, since the master control is outside of the control curves group, I just added it to the control curves layer. So I'm testing to make sure that all of our controls disappear on visibility. So I'll hide those. I'm going to test to see that all of our joints disappear. That's correct. I'm going to test to see that our IKs disappear, and that is also correct. Geometry still shows up fine. So I'm going to take geometry off reference so I can actually bind stuff. I'm going to bring back the joints, and I'll bring back the controls. You basically never need to see your IKs again. So I'm just going to leave those on non-visible and reference. Alright, so first step in binding. Actually, so let me discuss the two types of binding. There's actually a third type of binding in Maya 2011. The name slipped my mind right now. But I'm going to do rigid binding, which is the easiest type of bind. But a lot of game engines, I'm not 100% sure UDK requires smooth bind, but I know game engines like Panda, everything like that requires smooth binding. So smooth binding is the more complicated one, the one that people usually hate because, although rigging took forever, people actually spend longer on smooth binding, sometimes just binding the skin to the skeleton. So we're going to go ahead and do that. We're going to start off nice and easy, just with one of the legs. I am going to, again, do rigid binding, and you'll see the difference between rigid and smooth binding. So I'm going to select the foot, select the ankle right here, ankle joint. I'm going to go to skin, bind skin, and I'm going to do rigid bind with the option box. And I'm going to take this off complete skeleton so it doesn't try and bind the whole skeleton, so it doesn't try and bind this block to the whole skeleton. So I'm going to do selected joints because I only want to bind the foot to this foot joint. And I'm just going to hit apply. So right when I do that, you can see that the foot moves with the joint. So I'm going to just do that with the other joints. I'm going to hit G to repeat the last action, and G again. So as simple as that is, our leg now moves correctly with our joints. Just like that. I'm going to shade it up so you guys can see it a bit easier. That's 6 on the keyboard. But see, now everything works probably, and you can probably see how the pole vectors work a little bit easier now. Just like that. Alright, so, let's see. Alright, so I'm going to zero this out again. Alright, so that's rigid bind. Rigid bind, visibly that's rigid bind. What rigid bind actually means is the way that binding works is it basically looks at each vertice on the geometry, so all of these vertices around on each corner, and basically says how much influence a single joint has on that particular vertice. Rigid bind means that 100% of that vertice weight is constrained, is constrained to the joint. So that that vertex is completely constrained to that joint. Smooth bind means that it's not 100%ly constrained, meaning that, like, let's say if you look at your skin, just look down at your arm right now, your forearm, and go ahead and rotate your wrist. And you'll notice if you look at the skin in between your wrist and your elbow, that you get kind of a nice transition of skin. That's because if you're looking at your character's arm and you imagine a ring of vertices going around your forearm, those vertices are basically 50% constrained to the wrist joint, 50% constrained to the elbow joint. So you get a nice transition of skin. It's not a hard angle. So I just want to basically, just the way that I constrain the leg is how you constrain the rest of the body. Very simple. The upper body right here will be constrained to the hips upper joint. The lower body, it will not be constrained to anything because see, it already moves the legs when I rotate this right here. Just make sure that you constrain the upper body, this torso section, to the hips upper joint. Other than that, rigging the rest of the body, binding the rest of the body is pretty straightforward. Now, I want to show you guys what smooth bind is. So I've got this example right here. So imagine this is an arm. It's just a standard IK setup for arm. And so you can see that these vertices right in here specifically, they've got a bend to it. By the way, if you do rigid binds and you try and do an IK setup, this whole cylinder would just be completely straight right here because all of these vertices would be 100% constrained to this joint, regardless of what these other joints do. So weight painting is, I mean, if you ask anybody in the animation world, almost everybody hates weight painting. You can get paid a lot of money to do weight painting because nobody wants to do it. Basically, you want to paint the influence of vertices that each joint has on the vertices. And there's two ways to do this. One is the component editor, where you see, let's see, I'm going to hide the joint, Control H, hide the IK, Control H, and I'm going to go into vertex mode and select all these vertices. I'm going to go to Window, General Editors, Component Editor, and then I'm going to make this box bigger and go over to Smooth Skins. Now, we only have 3 joints here. Imagine that you had your whole skeleton, you have one mesh, you've got a game character that's anywhere between 5,000 and 15,000 polys. Some game characters now are like 50,000. I know UDK, like, I think the average is 15 to 30,000 right now. But you can see right here each vertex number and the weight that each joint has on it. I mean, if you box up less, you can do less. You can select all these and type in your own number for them, and it will divide it up evenly. And so that's the tedious way of doing it, but it's useful if you want, like, let's say all of these joints to be an exact number. The easier way of doing it, the more visual way, is basically using the Paint Weights tool. And I'm going to do this briefly. So we're going to do Edit Smooth Skin, Skin, Edit Smooth Skin, Paint Weights tool, Paint Skin Weights tool. So we get this over here. We've got our joint names here. It would be helpful if I actually named, but joint 1 is the parent, joint 2 is right here, joint 3. You never want to replace, you never want to place with a value of 0. I just don't even touch replace, I don't touch scale. You want to do add and start off with a low value, maybe 0.15, and you want to put your skeleton in a weird position that would be feasible, but something that's far enough away from the rig position. And I think I'm actually going to just wrap this up next video because it's kind of important to see the before and after. So I'm going to go ahead and put this back the way it is, copy it, and come back and tell you guys how to use the Paint Skin Weights tool. Alright, see you guys next video.